I want to cover quickly some of the inspection equipment that we use in our assessments. What you've got is a photo in front of you that's just got a range of tools and technologies. They range from simple automotive feeler gauges to increment bores that are used by foresters to advanced drilling techniques to ultrasound-based technologies. So all of them are discussed in detail in the condition assessment manual, as well as where you can get them, where you could rent them from, how to use them, and how to interpret data from them. So I'm not going to go into gory details of every instrument. I'll tell you this, we have worked with virtually every single type of technology I'm going to present, and they all add value, and they all can help in an assessment. Let's look at sounding. Sounding is a very commonly used technique. It does require some skill, and it only gives you a partial picture of the extent of decay. It doesn't tell you how severe it is, where it is. And the key point here is it does not detect decay in its earliest stages. So usually by the time that kind of thing is good for you, it's severely deteriorated and definitely needs some attention. So sounding with a simple hammer works quite well, but increment bores. This is a forestry tool that we use. A lot of our colleagues in the forestry profession use it to get age growth or growth rings on trees. Basically, it's a hollow tube that is inserted or drilled in by hand into a tree, or in this case a wood member, and it provides a core sample. You pull that core sample out and it tells you a lot of things. It can tell you if there's a void there and the extent of the void. So it gives you a really good indication of how much net section is left. It also allows you to take those core samples out. You can put them in a little plastic bag, and you can send them to a laboratory and get them analyzed for the presence or absence of decay, if you really go to that extent. Some people can use those, would indicate that you can use those for a potential species identification. That may be enough in many cases to do a species ID. The thing I use them a lot for is to determine the presence or absence of a preservative treatment and how deep that preservative penetrated into the section. So very good tool, very inexpensive. We've used them all. They're in the book. Probably pick one up from the neighborhood of a couple $100. So one thing I do recommend for anybody using these, please, when you pull those things out, replug them. You can buy preservative treated wooden dowels or wooden dowels of a species that is very decay resistant, like an oak or something like that, because I've seen people where they do a great job on all this and they put an aspen plug in there and it's a perfect thing for decay. So great tool, great technology, very inexpensive, really good on heavy timber construction inspection work. We use it a lot. Resistance drilling is really what it is. It grew out of the concept a lot of us used in the past, that the torque resistance for a drill going into wood is strongly correlated to the density, and we found out later, to the capacity of the wood members. People have actually commercialized that, so it's very good for locating decay and termite damage. As we talk here, the drill resistance is very well correlated with density. What it does is measures the relative resistance as a rotating drill bit is driven into the wood, and it displays that relative density profile as it goes across the members. So it's a really nice tool. There's several different places you can get it. Again, it's in the Wood and Timber Condition Assessment Manual. I use these things a lot, especially in heavy timber construction. And it'll give you a profile. They have equipment that can be hooked right up to a laptop, and you can download the results. It is extremely good at picking up decay and decay areas in standing timber as well as for heavy timber construction. So we use it a lot. Ultrasound or stress wave based technologies, basically what we look for here, it works on really good on heavy timber construction. we try to send a sound wave perpendicular to the axis of the fiber, so across the member. Very good with heavy timber construction. We use it a lot. What we found is that the speed of sound transmission is extremely sensitive to the absence or presence of decay. Well known now, well published, good baseline laboratory work, as well as a lot of field work to support that. Basically what happens is that most of these pieces of equipment, and there's probably a half a dozen different manufacturers of it, they take and they put some kind of sensor on one side of the wood and a corresponding sensor right across the member, and it imparts a wave to flow through the wood, and it simply measures the time it goes from A to B. And knowing that, we can get an indication of what the speed is, and knowing what those speeds are for sound wood for various species, we can give you an indication of whether or not there's decay in there. So really is a nice tool. We've used this a lot. Several different types. They're all in the Wood and Timber Condition Assessment Manual. They range in price probably from about $1,500 to about $10,000, depending on what kind of data acquisition, what kind of printouts you want, but well-established technology now and used quite a bit. There's a whole chapter, because these are used so frequently, there's a whole chapter dedicated to their use, and there's tables in there on various wood species that tell you what baseline values are for good sound material. Another thing we use quite a bit is moisture content. As I've said several times, that the wood needs moisture for the decay to come in and take it. Normal use for wood is, for sound wood, we figure that the moisture content should be somewhere around 6 to 12%, especially inside buildings. It gets lower than that in the winter up here in northern Wisconsin. Exterior moisture content should be somewhere in the neighborhood of 10 to 20%. When we start to see moisture contents above 20, 30, definitely 30%, we start getting concerned that their potential is there for biodeterioration. And so one tool that's used extensively in the wood industry is a moisture meter, and we recommend them as an initial check on the moisture content of wood. And there's a whole series of guidelines on moisture meters, where to get them, how to interpret them. They basically measure the electrical resistance of the wood, and we found that that's very indicative of what the moisture content is or what the moisture levels are within the wood. And it's a very inexpensive, well-adapted technology. We use that a lot on a variety of structures. Now, having said that, it's not necessarily that the moisture's in there, but if moisture's in there, that's one of those three pieces that are necessary for decay and biodeterioration to happen. If the moisture content is low enough, we don't worry about it, but if it's high enough, then we have to be concerned that the potential is there. So really nice tool, very, very appropriate, and very relatively inexpensive.